Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome again to this 12-week course on circular economy for sustainable buildings. Last class we saw about circular economy specifically in the built environment. This time we will continue that to some extent and then we will also look at circular economy in other sectors. So, this class we will look at circular economy in the built environment as well as other sectors. Last time we saw in the built environment, education is a very important aspect for us to promote circularity. So, what do you mean by education and stakeholder actions? Under this, the first thing we should do is policy actions. Now, the government should provide clear guidance for industry to encourage education, capacity building, and investment for circular economy. Whereas the local authorities should develop expertise in circularity and also whole life carbon assessment, integrating this into the overall planning applications. Now, if we look at industry actions, what can we expect from the industry if we are looking at educating everybody for circular economy? Conducting skill mapping to identify gaps and implement the policies to address them. Then industry should also establish net zero carbon training plans which must mandatorily include circular economy principles for all built environment professionals. Then the industry should also look at professional institutions that can offer training and resources for industry-wide skill improvement, because we need to have good labor force even to disassemble a building. We need to have good trained designers, architects and draftsmen who can draft the dismantleable solutions. So, there is a lot of training that has to be given to a variety of stakeholders. Then we should also pull in NGOs and associations to support sharing of best practices. Besides, developers and investors to value buildings as material banks and assets rather than something which is stuck and it can be demolished and thrown to the landfill. Architects and engineers should educate clients on circular economy principles, aesthetics of reused materials, longevity benefits, and also value of reused materials. There should be intense collaboration with contractors to design for disassembly and ensure proper material salvage practices so that there is least amount of wastage when you start salvaging the materials. Then, transforming demolition contractors into skilled deconstruction experts. So, there is no demolition, but there is systematic deconstruction to happen. Then contractors should train on material reuse and life cycle extension techniques. Also, quantity surveyors and project managers should evaluate circularity along with cost when they take any decision on a project. Engineers and manufacturers should collaborate with insurers for warranties on reused materials, because there is a general belief that reused materials are not strong and they may not be able to give a safe and secure environment, which is not true completely. So, we need to pull in these insurers also. Very, very important. I am happy that I am a small part of it. Universities should incorporate circular economy principles into design courses as well as in their curriculum. Lobby government policy makers for long-term sustainable thinking, which means it is going to take a village to raise a child. It is going to take a whole gamut of stakeholders to ensure that we will move into circular economy, at least when it comes to designing and executing buildings, or rather circular economy in built environment. Now let us see how is the concept of circular economy in another important resource, that is water management. Now, when it comes to water management, first is what we have to do in order to move to circular economy. We should reduce water losses by boosting water efficiency. So, water conservation through reduced losses such as leakages, reduced leakages and so on, and also water efficiency. How this has to be achieved? To some extent we have seen in the first few classes. Then reuse of water, this also we have seen. So, reuse water that needs minimal or no treatment for the same or different processes. So, this is more like grey water, using grey water for flushing. This is a good example of that. Then recycle resources and wastewater. So, recycling of water, again we can say grey water or even storm water, to some extent black water also. Restore, return water to source at the same quality or better quality. So, this is the analogy for rainwater harvesting. All of this we have seen, and that is what I am trying to say, how resource conservation is linked to circularity. This is what I was trying to tell in the beginning and establish the case. Then recover resources from wastewater and put them to use. So, if you have any resources in wastewater, say solid waste. So, solid waste management is another example of this. All of this to some extent we have seen in the first few classes. So, we need to look at circular economy for various resources, and when it comes to circular economy of water, this is also directly related to how architects and designers manage the use of water in their building. Next, we will see circular economy in textiles. So, when it comes to circular economy in textiles, let us look at the first thing, which is raw material extraction. So, the material is extracted, which is say cotton for example, and then goes to textile production. From textile production, the clothing happens, or the weaving and things like that happen. From there, it goes to buying, selling or retail, and that is where the public is involved, and then the public uses it. So, this is a public domain. The public is involved in this domain. which are primarily consumers who use, care and dispose. So, once you don't need that clothing or that material, you need to collect the so called waste, or so, when I say so called waste, I mean pre-loved or used textile, and then this can go to recycling through municipality textile collection, as well as the retailers who can recycle the fabrics and get the fibers from the fabric. This goes for recycling and it can again go back to the textile production, which again goes through the clothing manufacture, and this cycle can keep on happening. Sometimes when the product is no used, it need not be a product which is damaged, in which case one can repair it and again send it back into the economy of buying and selling. This is how circular economy in textiles can happen. A big complicated diagram for a simple thing that most second or first siblings have done. Anybody who has an elder brother or sister, definitely you have used hand-me-down dresses, clothes. You will get, at least my generation of people, we would get clothes during Diwali or probably another no festival. That's it. No new clothes for birthdays and New Year's and all that. And if you are a younger sibling, you will definitely use hand-me-down clothes, hand-me-down books, textbooks also. Every year we won't buy textbooks. Our siblings' textbooks only we will study. It will have all underlining, all oil patches and things like that. We'll still use it. Hand-me-down school bags, compass box. I don't know whether you people even know what a compass box is. All this we had been doing. But over a period of time, we became such a consumer-based economy that no, everyone wanted to consume new, more, and that greed has led us to this situation. So we are saying, let us go back to those golden days which we have lived as our normal life. Let's see the challenges and barriers now. First challenge is it's becoming a fragmented responsibility. Fragmented responsibility means the burden of addressing waste management and resource use cannot rest solely on one body. It cannot be on companies or government or consumers, but it has to be a collaborative effort. Only then it can be successful. Second is there is lack of coordination. So, effective solutions will require innovative public-private partnership. Just isolated effort by some group or a stakeholder is not sufficient to solve large-scale problems, and therefore, we need coordinated effect. Then third is the financial barrier. Now, investments in circular economy, they face a lot of challenge because there is some risk involved for private investors. So, you need to balance the funding model along with the private public sources which are necessary to reduce risk and improve efficiency. Then fourth is policy gaps. There is a definite need for government policies that protect public interests while encouraging innovation and risk taking by private entities. Then fifth is social inequity. So, vulnerable population should be actively involved in designing circular economy solutions in order to address the concerns about job security as well as health impact. And then there is this no challenge of missed opportunity. Sometimes delays in forming coalitions or taking proactive steps could result in lost market opportunity for early adopters of circular economy practices. And then we have complexity of implementation. That is, achieving circularity requires a unified and strategic deployment of financial, intellectual, and operational asset across various sectors. In design specifically, design is a strategic component that influences waste generation in construction projects. Now, there are three main strategies which are identified in this category if we want to go circular in design. First is design for waste prevention. So, if we look at design for waste prevention, we should focus primarily on minimizing waste through reuse or recycling strategies right from planning to execution phase. For this, there are several tools which can be helpful. It could be BIM, which aids in life cycle management, which aids in waste reduction and material recovery forecasting. Of course, there is a challenge that there is additional cost in terms of storage and labor involved, and also we have very limited knowledge on construction practices for circular economy. The second one is design for disassembly and deconstruction. What happens when you design for disassembly? You promote usable and recyclable materials through your prefabricated components. Because of this, you can reduce waste, you can lower the cost, and you can also save time. It has its own challenges, that the limited application due to site specific conditions and also general lack of standards. The third one is use of prefabricated elements, or I will say even modular elements. If we start prefabrication in facades, drywalls or slab, we can reduce labor and waste. It cuts down 65 to 80% of construction demolition waste. We require an industry-wide adoption and standards in order to make this use of prefabricated elements prevalent. We can also use strategies such as waste prevention, disassembly, prefabrication that can enhance sustainability, reduce construction demolition waste, and support the circular economy with tools like BIM and prefabrication methods. So, in order to make circularity in design successful, we need to first reuse. So, reusing as a strategy consists of using already applied or harvested material, construction elements and building materials to meet either their original or different function. So, if you salvage brick from wall of one building, you could probably use that brick for wall of another building, or maybe as a flooring for another building. So, it could be for the same purpose or for another purpose. Thus, materials and components can be directly reused, or they can require little processing through applications of. First is repair. What is repair? Repair is focused on returning used products to working conditions, and this is limited to assembly and reassembly of fixed parts. Second is refurbishments. Refurbishment consists of improving the quality of the used products by using simple actions such as disassembly, inspection and replacing of components. The third one is remanufacture. This is aimed at providing quality of used products according to certain specific standards which are as rigorous as for new products. The next second strategy is recycling. So, recycled content in construction materials can offer us many environmental benefits as compared to raw materials. Now, this recycling can reduce construction and demolition waste that goes to otherwise landfills. It can decrease the demand for natural sources. Also, it can lower energy consumption in the manufacturing process for construction and other industry. Now, if we look at a general framework, recycling treatments can be applied through these three typologies. First is the closed loop system. So, what is the closed loop recycling system? In this system, salvage material can substitute the original virgin material in a 1:1 ratio, which means there is zero waste. Taking window as a unit from one building and installing that window as a window in another building. That is a closed loop recycling. Second is semi-closed loop recycling, in which you use the salvaged material that can partially substitute the original virgin material, but you need to add some more raw materials to comply with quality requirements. And third is the open loop recycling, in which salvaged material is used as a partial substitute in the manufacturing of different materials. In this manner, we can enforce circularity in design. Now, when it comes to construction and demolition waste, there is ample opportunity for us to use the construction and demolition waste, because say in 2008 a study showed that construction and demolition is a significant waste stream, and if you look at 26% of waste, which is construction and demolition waste, that is less than 1/3 is currently recovered. So, 74% of construction and demolition waste remain unrecovered. Of this 26% which is recovered, which is approximately 160 million tons in the US, 20 to 30% is recycled or reused, and 70 to 80% gets discarded. Of this 20 to 30%, where is the potential application? Now, this 20 to 30% is recycled and reused for whatever material it has. Now, if you look at the other discarded items, which is about 70 to 80%, you can see where all it goes. So, the composition of discarded construction and demolition waste is largely lumber, which is wooden flooring construction material, that forms 40%. Asphalt products, they constitute 14%, and they can be used for road building material. Then you have soil or fine aggregates, they can be used to reuse of soil after treatment, and that forms 11%. Concrete, rock, brick forms 11%. It can be used in gravel, erosion control, and even as aggregates, very low quality aggregates. Gypsum board, which is a fertilizer additive, that comprises 10%, and other building materials comprise 14%. So, this is the composition of discarded construction and demolition waste. So, this is the composition of discarded construction and demolition waste. So, what are the opportunities we have now for circularity in that construction and demolition waste sector? So, first is pre-construction stage. Now, in this pre-construction stage, we need to focus on waste minimization at the time of planning and design itself. And we should start using recyclable or reusable materials. We should be able to implement efficient design practices to reduce material waste. Besides, the other aspect is construction and building renovation stage. So, here you need to manage materials effectively during construction or renovation, minimize waste on site, and identify surplus materials in order to reuse or recycle. Emphasize proper on-site waste management practices. The third step is collection and distribution stage. In this stage, we can segregate different types of waste post construction. After construction, you segregate the different types of waste. You ensure efficient logistics and treatment practices, and you use direct materials to appropriate recycling and recovery facilities. The fourth is end of life stage. Here, you manage responsible disposal during demolition or decommissioning of structures. You can maximize diversion of materials from landfills through recycling and recovery strategies. And fifth is material recovery and production stage. In this stage, you can recover materials like concrete and metals from the construction and demolition waste. You can reinforce production cycles by recycling materials into some other new product. And you close the loop in circular economy by integrating recovered materials. Also, the construction and demolition waste sector can promote circularity by addressing waste management throughout the construction life cycle. Each stage contributes to sustainability and minimizes environmental impacts. Thus, we can have closed loop recycling, semi-closed loop recycling, and open loop recycling. Based on the material and the strategy you use, you could either reuse the material or send it for energy recovery or send it to recycling plant or on-site recycling. These get transported and go to the manufacturing unit where it can come out as a different material with partially recycled cement or same material with partially recycled cement. If it goes to energy recovery, backfill and residual waste, it will go to landfill. But before that, we can see whether we can give any other use to the material such as embankments, bases and sub-bases for road, or even incineration plant where it generates electricity. Then if we reuse the material, then you can go for direct reuse, or you can use it as a refurbishment or remanufactured item where it is transported and then the material gets stored and the same material then again goes back to the market for material inputs. So, this is the way in which we can use circularity in construction and demolition waste, where you have so many varieties of waste. You have masonry waste, metal waste, glass waste, component wise waste, gypsum board, false ceiling, so many wastes are there. But we need to actually, when we get the demolished component itself, there should not be much damage, and then we can take it to the various other stages. So, we can follow either the linear economy or the circular economy in the construction supply chain. If we follow the linear economy, which is a not to be encouraged, because under this you make the product, distribute, use, throw it to waste, and then as a landfill. Whereas in the circular economy, the material goes back and forth to the user and you use it as much as possible before you convert it into energy or a product of value. So, in conclusion, sustainability opportunity is extensively available provided we are able to redefine design, redefine construction, and also resource use in order to reduce waste and environmental impact, leading to sustainability. The second most important thing is collaboration, where we need to bring stakeholders to work together to drive circular practices. Third is we need to have innovative policies which support circular solution with effective framework, such as life cycle approach, which can integrate circularity into all building life cycle phases, or we can also have a future focus in which we build resilient, sustainable and equitable urban spaces. So, circular economy in the building sector demands collaborative effort across all the stakeholders, right from architect, planner, policy maker, construction company, the laborer, the client and community as a whole. We require innovative policies, financial incentives and education to bring about a culture that will value resource efficiency and also value sustainability for our own good and also the betterment of the future generation. So, with this, we will stop today's class and I will continue the next class with another topic related to circular economy. With this, we will stop today's class and meet in the next class. Thank you.